A demo here of PM Build, my build system that I'm using in my game engine, PM Tech, but I've also just moved it into its own repository so it can be used by other projects because I'm using it as at work for the same thing as well. What it is a cross-platform build system which can build, generate makefiles, build code, build data. You can hook in different tools and extend it and change it to build assets and game data for games typically. So you can target lots of different platforms. You can hook it into build machines so everyone's using the same build system as your CI. Just got like quite a lot of nice features and it's quite simple and lightweight to use. So I want to do a little demo of how it's working. I'm going to show this in the context of my engine PM Tech, and it has the examples. So I've got it on the right as terminal window where I'm inside the examples directory. I can run PM build help, and that's going to show me the help, but also this profiles, the various different profiles that I can build for. So in here you can see I've got Mac GL, Win32, Win32 Vulkan GL, and so on, lots of different platforms. If I run, because I'm on a Mac here, typically I'm going to be building for Mac, so I can do PM build Mac help, and this tells me which tasks, individual tasks are running for this profile. So in here it runs Premake, which generates Xcode projects. PMFX is shaders. Shared libs will copy any DLLs that are dependencies into the exe directory. There's render configs, which are like render pipeline descriptions in data. Base copy just copies various files from like a source directory to the binary directory. Texture C compresses textures. Models takes a Collada, converts them to a binary format. And PM build config is a config for this build so you can run it again for hot reloading. So if I open this directory, I can show you the contents of it. At the moment, it's just got assets, code, and that's it. If I run now PM build for Mac, what this is going to do is generate me some new folders in here. So it's generated a bin folder and a build folder. Inside the build folder are Xcode projects for all of the samples. There's about 40 in here: shadow maps, shader toy, SDF shadow, so on and so forth. In bin, we start to get data which has audio, render configs, fonts, models, shaders, and so forth. So that's what the build's doing now. It's still running. It's just optimizing models. The models is a custom build task for PM Tech. It's not in the core PM build, but it's very easy to add new ones. The way that the config, the build system is driven is from this config file on the left. In here you can see that the base profile, which contains generic steps that can be run on multiple platforms. Then we get down to Mac, which inherits from base, and it adds Mac specific tasks. So for example with PMFX, which is for shaders, the shader platform is for Metal, and it configures things like that. So we've just ran PM build for Mac, and if I go back into Finder and open up this solution, this is what's been generated for me. I can choose a project to build, let's say post-processing. If I build this from Xcode, builds and launch the post-processing demo. In addition to generating Xcode projects, you can also build from the command line. So I can do PM build make Mac, and I could do post-processing, for example, which is the one we just built, and it's building it again from command line. I can also change to launch this as well. So launch the post-processing build of Mac. I know from the previous build I actually built the debug one, and they get the _d suffix. So here you can launch from the command line, and then it also, if I run test as a command line arg, it'll run it as a test, and that will generate test results into here. It outputs basically screenshots of all the tests when they've ran. This one hadn't been cleared out, but so it's got everything in there, but it generates these, and these are compared against to do to make sure that there's been no regressions, basically. So you can build data, build code projects, build them from the command line, or open from a solution or workspace in Xcode's case. But I can also build for different platforms on Mac, so I could do pmbuild web, which is a mscriptum platform. It's just generating data now, so while that's building inside bin, inside build actually, we've got web as well as OS X, and this could happen for different platforms. If you're on Windows, you might be building for a PlayStation or Xbox, for example. So you've got multiple platforms where you can support them. On iOS is also you're building from Mac. That's another platform I can support. And I can also build from the command line the mscriptum version of the code, and I can also launch that in a web browser, which I'll do now. So let's say something like pmbuild web, make web, and we'll do subsurface scattering. This is runningemmake. You can also use on Windows, it supports MSVC, or you can have it set up using MinGW if you've got that set up. You can support Clang or GCC as well as Xcode build. You can support make files or Ninja builds as well as other kinds of builds, basically. So it's down to you. You can configure your own build tools. The ones I'm using are already hooked into pmbuild. So the linking step takes a little while for mscriptum in debug. The release build is much quicker. But now if I pmbuild launch web SSS_D, because it's the debug build, it launches me an instance of Google Chrome, and here is the subsurface scattering demo running inside a web browser. That's about it, really. The pmbuild repositories on GitHub, I'll put some links into the description for these things, and check it out.